Okay, so today I want to talk real quickly about two types of exponential growth. Okay, we've got growth models, which are often represented by this formula. We have the principal times 1 plus the rate of growth taken to the power of time. And then we have decay models, which are also with respect to time. So we have the original amount equal to the principal amount, or principal invested, times 1 minus the interest rate, or the growth rate in this respect, taken to the power of time. Now, these two types of models actually apply to many different facets. Normally, when we use these models, we talk about two models. We talk about appreciation, and we talk about depreciation. Appreciation and depreciation in this sense is basically what happens to the value of an item, product, asset, good, or material over time, or with respect to time. So, for instance, let's say you buy a car. Okay, so you buy a car for, let's say, $12,000. Over time, the car depreciates by 14% per year. Well, let's go at 13% per year. What is the value of the car after 5 years? Well, first off, we've got to understand that we've got keywords or sight words, and one of the sight words that we focus on in these types of models is normally it tells you how it grows. So it says the car, or you buy a car, $12,000 over time depreciates by 13% per year. Okay, so in essence, we've got our formula, and we know one, is it growth or is it decay? And obviously, the value of the car is decaying over time. So we're going to use A equals the principal amount times 1 minus the rate over time. Or not over time, but taken to the power of time. So with respect to time. So the principal amount is actually equal to the amount you originally invested. This right here would be the principal. Okay, and not a person that operates a school, but basically it's your initial investment in terms of how much you spent or how much you earned. Okay, so it can be an investment, it can also be a return, it can be many different facets. Basically, we're looking at the beginning value of a specific item. Well, the specific value, or the initial specific value, we said is $12,000. And it depreciates with respect to time over 13% per year. So we're going to put that percentage into decimal, taken to the power of time. Okay, so that's our formula. Well, right here I ask, what is the value after 5 years? Well, this tells me that t equals 5. So now I'm going to substitute in that value. So when I do that, I'm going to get equals $12,000 times 1 minus 0.13 would be 0.87, taken to the power of 5. So basically, we're seeing what happens to the value of the car, understanding the fact that it loses 87% of its prior value each year. Okay, well, plug it into your calculator. And we find out that the value of the car after 5 years is actually equal to $5,000, or $5,981.05. So after 5 years, your $12,000 car is only worth about $5,000 and $981.05. So this would be a method of where we have depreciation. Now, normally things decay over time. It works out that way. But there are some things that grow over time or grow with respect to time. So let's talk about bacteria. Okay, bacteria happens to actually be a fascinating aspect when we talk about a principal amount of growth. Okay, now let's say you buy an asset. Before we get into bacteria, let's do another one. You buy an asset for, let's say, $43.12. Okay, let's say you buy into an asset for $43.12. Your investment grows in value by let's do a modest amount, 7%, 7.2% per year. What would be the value of this investment of your investment after, let's say, 7 years from now? In 7 years. Okay, well, basically, we're going to look at the sight words. The investment grows. We buy for $43.12, and investment grows by 7.2% per year. What would the value be in 7 years? Okay, so one thing, we know that it's growth. So that means we're going to use the model. The amount accrued equals the principal times 1 plus the rate of growth taken to the power of time. So we're looking for the amount appreciated with respect to the principal and the growth rate with respect to time. Okay, so basically we just plug in all the numbers. The original amount was $43 invested. Okay, so A equals $43.12, and we know that our growth rate is that it growed by 7.2% per year. So 1 plus 0.072, which is 7.2% in decimal form, taken to the power of time. Now, in this instance, we know t is going to equal 7 years. So I want to know what happens after 7 years it is appreciated. So I get the original amount, $43.12, times 1.072, taken to the power of 7. If you plug that into your calculator, you're going to find that you'll get 43.12 times 1.072 taken to the power of 7 is going to be equal to $70.15. So after 7 years, sorry about that. So after 7 years, we find that the investment is worth $70.15. Now, that means you have about, if you subtract this price right here from this original price, you'll find that you gained $27.03 off your original value. So you have a gain, okay, the difference of the two after time has passed is that you have a gain of $27.03. Believe it or not, this is actually how some of your investments grow in the stock market. Okay, so hopefully, right? I mean, stock markets are not always secure, so your investments can go up and down. But let's say you know that the average rate of return on your investment is a certain percentage. You can figure that out and plug it in and find out what the value of your asset would be in 4 to 5 or 6 or 7 years. So that's one way you can actually utilize to monitor your portfolio in real time. On top of that, you can even create a live macro or a database that would actually predict how much, if you spend money, how much that money would be over, in 3 or 4 years out. Now, granted, you're going to have a margin of error because you don't really know what the market's going to do on a day-to-day basis, but assuming that your rate of return is constant and not changing, which we all know it is, you can figure out what it should be, and that helps you determine your loss, because the main focus of the company is to always do better than they did the previous day, kind of like how we all are. Okay, so this is a good representation of how we actually have appreciation and depreciation. Things lose value, things gain value. Normally, things that gain value are investments. Things that depreciate are assets normally that you buy, like consumer commodities, like a car or a pair of Jordans or stuff like that. Sometimes it's going to depreciate over time. Now, there are some items that appreciate with time, and those would be like a pair of Jordans after 10 years, or a pair of Air Force Ones from the 80s, or a collector's, muscle car. So everything appreciates and depreciates with respect to time. So it's just something you might want to be familiar with. Anyway, just remember that these two models are very important, and on your test, you're not going to have a formula chart, so you need to make sure that you remember these two types of models. These are forms of exponential growth, so you need to remember that. On top of that, it's very useful in business classes and business economics and accounting and finance. I mean, this basic function just keeps popping up everywhere, so it is very important that you understand exponential growth models.